Three-way switches are a handy device in residential wiring. They allow you to turn on a light from two separate locations, like at the end of a hallway or the top and bottom of a flight of stairs. In this video I will describe their function and diagnosis of problems with a light circuit using three-way switches. Let's first look at the light and what it requires to turn on. Any light in a residential application needs two wires to turn on. It needs a hot wire, which is black, and a neutral or ground wire, which is white. Electrical code says that only hot wires can be switched, which means that the ground wire runs continuously all the way from this light one way or another all the way back to the panel. So the switches don't control the white wire. The switches only control the black wire, which is the hot wire. So in a three-way switch circuit, we have the white wire going all the way back to the main panel of the house, but the black wire goes to the switch circuit, and it looks like this. This prop that I've made for your YouTube viewing pleasure represents switches at either end of a hallway. They're both identical and they're both known as three-way switches. A three-way switch has three terminals. One here, and one here. This top one all by itself is called the common terminal. It will either have the power going out to the switch, or on the other end of your hallway, the power coming in from the panel. The three-way switch doesn't actually turn on or off. It just alternates connecting this common terminal to either one of these bottom terminals here. In this position, the switch is connecting this terminal to this terminal. In the alternate position, it's connecting this terminal to this terminal. So in order for our light to come on, we need to make a continuous connection from this wire coming in from the panel through the switch, through one of these wires, up through the switch, and out this terminal to the light. Let's look at the three-way switch circuit in action. When this switch is down, it's connecting this wire to this wire. If the switch is up, it's connecting this wire to this wire. It's the same arrangement with this switch. Being up, it's connecting this wire to this wire. Being down, it would connect this wire to this wire. So right now we have power coming in here. Because the switch is down, it's connecting this wire down to this red wire. We'll follow the red wire over to this switch, where since this switch is up, this terminal is not connected to anything. So the power terminates here and the light doesn't come on. If we switch this down, the light comes on, because now we have a connection between this terminal and this terminal. If we switch this one, now we have power going here through the switch out through this terminal, and the light is off because this terminal is not connected to anything. We have these two connected. So we can turn it on and connect that terminal to that terminal, or we could also turn it on here, because either way we have a continuous circuit. Right now the power is coming through here, through the red wire, and up here. The beauty of this system is that you can control a single light from multiple locations. Let's troubleshoot a system that doesn't work. First, take off the switch covers for the switches at either end of your hallway or staircase. We need to figure out where the power goes in and where the power comes out. To do this, use your handy multimeter set on AC voltage. Connect one terminal to the common of the switch and the other terminal to the white wire, which will also be in the switch box. And find the one that reads 110 volts or 120 volts. So that's this one, power coming in from the panel. If we do that on this switch, which will look the same in your house because they don't have these handy labels, you'll notice that there's no voltage. You can also touch the black terminal to your bare ground wire, also in the switch box. Either one should give you a voltage reading. So once you determine which of your switches has the power coming into it, you need to make sure that power is going out from it correctly. To do this, keep one of your test leads connected to the white wire or ground, and the other one to either terminal of the switch. It doesn't matter which one. So we'll try this one. We don't see any voltage. And then we'll try the other one, and it has voltage, which means that in this position the switch is transferring the voltage from here to here. Let's go the other way. The light turned on here because this one's working, but it may not in your case. Keep your terminal touching the ground wire, and there should be voltage here. So what we're looking for is, you want to make sure that voltage is carried from this wire to either one of these wires as it should be. If you can't get voltage to come through either one of these wires, the switch is probably bad. If that checks out, go to your next switch and verify that you have voltage coming through these two wires. So touch your one terminal to the ground and try one of these terminals on the bottom. So this one has voltage coming through it, so we know that one works. Then go over to your switch and make sure that you have voltage going to the other terminal, which it does here. If it fails this test, then you have a break in the wiring somewhere between the two switches, or they aren't wired correctly. If you have voltage alternating between these two terminals but the light doesn't come on, then this switch is probably bad. Oftentimes these switches aren't wired correctly because they can be confusing. You'll notice that you have two black wires in the same switch box. Some clues to help you determine which one is supposed to go where is the one encased with the red wire should be going to these two terminals, and the one coming in from the panel or out to the switch will be encased with a white wire. So that can give you a clue as to which wire should go where. Thanks for watching my video.